very important question for the basis and dimension. Let W1 and W2 be the subspaces of four-dimensional vector space R, which is defined as these. Then we need to find the basis and dimension of W1, W2, their intersection, and the sum of the subspaces. So let's move on for W1. To find the dimension of W1, it is given to us that W1 is a subspace having the vectors A, B, C, D of this kind such that B minus 2C plus D is equal to 0 and A, B, C, D is belonging to the set of real numbers. So this is the condition given to us. So let B minus 2C plus D is equal to 0. Please mark this as 1. Now since 1 is a system of one linear equation in 4 variables, because I'm having vectors of the kind having the elements A, B, C, D, right? So there are 4 variables. So number of free variables equal to, it is a number of variables, that is 4 minus the number of equations. So I'm having only one equation over here. Yes, so writing here 1. So this is equal to 3. So the number of free variables is equal to 3. So from this equation, we need to choose the free variables. Always try to choose that variable to be the free variable whose coefficient is not equal to 1. So here I am choosing C. And now I have to choose 2 more free variables, right? Out of A, B, C, D. In this equation, I have to choose either B or D. It is your choice. So I am choosing B, so that if I put the values of B and C, I get the value of D. So that if I give any value to C or B, I can get the value of D, right? Okay. So either you have to choose B or D. And the last free variable is A. So now I have to give the values to these variables so that I can get the value of D. And on the basis of this, we find the basis of W1. Okay. Now, what values you have to give? Just remember the format. If you are having 3 variables, then just write the format as the 3 by 3 identity matrix. So it is 1, 0, 0, 0, 1, 0, 0, 0, 1. That means first A is taking the value 1, B is having the value 0, C is having the value 0, right? So for A equal to 1, B equal to 0, C equal to 0, we need to get the value of D from this equation. Now for the first set, B is 0, C is 0, so D is 0. So D is 0, right? The another set, 0, 1, 0. So now B is taking the value 1 and A and C are taking the value 0, 0. So C is 0, B is 1 and D will be equal to then 1 minus 0 plus D. That is 1 plus D equal to 0. So D equal to negative 1. And now to give the values as 0, 0, 1. Now here A and B are 0 and C is 1 this time. So now here B is 0 and C is 1. So D will be equal to 2. So from the first set, we are getting the basis as, we need to write in the format A, B, C, D, the values A, B, C, D. So the value of A is 1, B is 0, C is 0, D is 0. From the second set, we get 0, 1, 0, negative 1. From the third set, we get 0, 0, 1, 2. So these are the bases for W1. And how many elements are present in the bases? 3 elements. So the dimension of W1 is 3. Similarly, we need to get the basis and dimension for W2. What is the condition for the W2? A plus B equal to 0 and C is equal to 2D, right? I can write this as A, B, C, the vectors of these kinds such that A plus B equal to 0 and C minus 2D is equal to 0, where A, B, C, D is belonging to the set of real numbers. So writing these two conditions, so let A plus B is equal to 0 and C minus 2D is equal to 0. Please mark this as 2. So this 2 is a system of 2 linear equations in 4 variables. And the number of free variables is equal to the number of variables minus the number of equations, that is 2. So this is equal to 2. So how many free variables we can take? Only 2. So in these two equations, try to choose that variable to be the free variable whose coefficient is not equal to 1 first. So I'm choosing D. And one more free variable you need to choose. You cannot choose C because already you have chosen D, right? And from the first equation, you can choose either A or B. So I'm choosing A. Okay, now we need to give the values to these variables so that we can get the value of B and C. Because these are two variables, remember 2 by 2 identity matrix. So first is 1, 0 and then 0, 1. So A is taking first the value 1 and D is taking the value 0. So for A equal to 1 and D equal to 0, we need to get the value of B and C. For A equal to 1, we get B is equal to -1. For D equal to 0, we are getting C to be equal to 0. So for these two values of A and D, we are getting the value of B as -1 and the value of C is 0. And now giving the values as A equal to 0 and D is equal to 1. A is 0 and D is 1. For A equal to 0, we get B equal to 0. For D equal to 1, we get C equal to 2. So from the first set, what are the bases? The format is A, B, C, D, right? So write like this. The value of A is 1, then the value of B -1, then the value of C 0, and then the value of D. And then another element 0, 0, 2, 1. So these are the bases for W2. And the dimension of W2 is 2 because the number of elements are 2. Now to get the dimension for the intersection of the subspaces, since W1 is given to be as this and W2 is given to be as this, then what kind of element present in W1 intersection W2? All the vectors of the kind A, B, C, D such that you have to write all these three conditions. Right? Okay, let's write these equations now. So number of free variables are the number of variables minus the number of equations, 3. So 4 minus 3 is 1. So we need to choose only one free variable, right? Okay, since 3 is a system of 3 linear equations in 4 variables, so the number of free variables is equal to the number of variables minus the number of equations. So that is equal to 1. So choosing that variable to be the free variable whose coefficient is not equal to 1. So I'm choosing D. So whenever you are having only one free variable, always give it the value as 1. Right? Okay. From the third equation, for D equal to 1, I get the value of C to be 2. And from the first equation, D is 1. I'm having the value of C to be 2. So from this, I get the value of B to be as B minus 4 plus 1 equal to 0. That is B equal to 3. And from the second equation, if B is 3, then A is getting the value -3. So for D equal to 1, C is 2, B is 3 and A is -3. And from this set, we are having the element for the basis to be -3, 3, 2, 1. Please remember, you always have to write the format like this. A, B, C, D, the values accordingly, right? Okay. So this forms the basis for W1 intersection W2 and the dimension for this is 1 because we are having only one element. Okay. Now to get the dimension of sum of the subspaces, and we know that what is the formula for this. So the dimension of sum of the subspaces is equal to the dimension of W1 plus the dimension of W2 minus the dimension of intersection of the subspaces. And we have found the dimension of W1 to be 3 and the dimension of W2 we have found to be 2 minus just now we have calculated minus the dimension of intersection just now we have found it is 1. So this is 5 minus 1, that is 4. So the dimension of sum of the subspaces is 4. Alright, thank you. Stay blessed.